Python data visualization libraries, and how to choose between them. 10 libraries, 1 decision framework, and the visual principles that decide whether any of them produce a figure worth publishing. Let's start with the single most useful distinction. Almost every choice collapses into one question: static or interactive. Static means Matplotlib, Seaborn, and Plotnine, publication figures, vector output, complete control. Interactive means Plotly, Bokeh, Altair, and Dash, web output, hover, zoom, a browser. Decide this first and most of the options disappear immediately. Here is the entire landscape on a single slide. Match the library to the destination of the figure: a journal panel, a notebook, a shared dashboard, or a full application. Everything after this is detail. If you remember only this table, you will choose correctly most of the time. Within any library, the question still chooses the geometry. Comparing magnitude across categories, use position on a common axis. Showing a distribution, show the actual points. Showing composition, prefer stacked position over a pie. Showing a relationship, use a scatter. The tool never decides this for you. Matplotlib is the foundation everything else is built on. It is verbose, and that verbosity is precisely the point. Every artist, every axis, every font is reachable. For a figure that has to satisfy a reviewer, in vector format, at 600 dpi, that level of control is not optional. Control only matters if you spend it well. Cleveland and McGill measured how accurately people read visual channels. Position on a common scale is the most accurate, then length, then angle, then area, then color. Put your most important comparison in position and never ask a reader to compare areas. Seaborn sits on top of Matplotlib and supplies statistical defaults. A single call gives you violins across cortical cell types, with a sensible palette and the legend already placed. Underneath, it is still a Matplotlib figure, so you can always drop down and fix whatever the defaults got wrong. Seaborn makes distributions easy, which makes it worth knowing which distribution plot to ask for. Boxes give quartiles but hide multimodality. Violins show shape but invent smoothness in the tails. Overlaying the points fixes both. A rain cloud gives shape, summary, and raw evidence in one column. Plotnine ports the ggplot2 grammar of graphics into Python. You build a plot in layers, data and aesthetic mapping, a geometry, then facets and scales. If you came from R, the syntax is already familiar. Output is static, so treat it as a Matplotlib alternative, not an interactive one. That grammar is worth internalizing even if you never use Plotnine. Data becomes aesthetics: position, color, size, shape. Aesthetics attach to a geometry. Scales map values onto pixels, and coordinates arrange them. Once you think this way, you stop picking chart types and start composing encodings. No library protects you from a bad color map. The rainbow fails because its luminance is not monotonic. Bright bands create edges where the data is perfectly smooth. Perceptually uniform maps like Virides and Magma fix this. Equal steps in value give equal perceived steps, and they survive grayscale. For log fold change, use a diverging map and anchor the neutral color exactly at 0. Set the limits symmetrically so the same magnitude of increase and decrease receives the same intensity. Watch what happens as the lower limit drifts. Nothing about the underlying data has changed at all. Roughly 1 man in 12 has a color vision deficiency, and red against green is the classic failure. Before exporting, simulate deuteranopia or simply check whether the figure survives grayscale. If it does not, encode that same difference a second time with shape, position, or a direct label. For expression projected onto an embedding, 2 settings do most of the work. Set the lower limit just above 0 and color everything below it light gray, so absence reads as absence. Then cap the upper limit at the 99th percentile, so a single extreme cell cannot flatten the panel. Plotly is where interactivity begins. The same scatter becomes hoverable, zoomable, and exportable as one self-contained HTML file. For an embedding of 100,000 nuclei, being able to hover a single cell and read its barcode, and its annotation turns the plot from a picture into a tool. Interactivity does not solve scale. At 2 million cells, every library produces a solid block of ink. Lowering alpha reveals density, but erases rare populations. Hexagonal binning and 2-dimensional density stay honest. Rasterize the point layer, keep the text as vector, or the file will never open. Bokeh targets dashboards and streaming data. Its server component pushes updates into a live page, which suits monitoring something still in progress. Per sample quality control while a sequencing run finishes, rather than a figure you generate once and freeze into a manuscript. Altair is declarative. You describe the encoding and Vigalite renders it, which keeps chart logic short and readable under version control. One caveat matters for single-cell work. Altair embeds the data into the chart specification, so large frames need an explicit data transformer or aggregation first. Pygal outputs SVG, so its charts stay sharp at any size and drop cleanly into a poster or a slide. It offers light interactivity and very little customization, and the community around it is small. Reach for it when you want a clean schematic quickly, not for a primary analysis figure. Geoplotlib maps coordinates, dot maps, density surfaces, projections. The obvious modern parallel is spatial transcriptomics, where every spot carries a physical position. Be aware, though, that the library has seen very little maintenance, so for spatial single-cell work today, dedicated tools are the safer choice. Dash, built by the Plotly team, turns an analysis into a web application in pure Python, no HTML, no JavaScript. This is how you hand a collaborator an embedding they can filter and subset themselves, instead of regenerating a static panel every time they ask a slightly different question. PyGWalker wraps a data frame in a drag-and-drop interface inside Jupyter. Point it at your cell metadata, and you can cross-tabulate donor, cluster, and quality metrics without writing any plotting code. It is an exploration tool. Anything you intend to publish should be rebuilt explicitly in Matplotlib. Whichever library you land on, a dot plot carries more than a heat map. A heat map shows one number per group, mean expression. A dot plot adds size for the fraction of cells expressing. That second channel separates a gene high in a few cells from one moderate across all of them. When comparing conditions, resist overlaying everything into one panel. A grid of small multiples sharing identical axes and identical color limits lets the eye scan differences directly. Those shared scales are what make the comparison valid. A faceted grid with free scales is several figures pretending to be one. Every library ships defaults that add ink without adding information. Heavy grids, boxes on all four sides, redundant legends, and drop shadows all compete with your data. Keep one font family, keep tick labels sparse and readable at final printed size, give every axis its units, and then stop. Treat every figure as code. Export vector for line art, embed your font so text does not reflow on another machine, fix the random seed for every stochastic layout including the embedding itself, and store the script beside the panel. Irreproducible figures are irreproducible results. In practice, the split is clean. Matplotlib, Seaborn, and Plotnine produce the panels that go into papers. Plotly and Dash give a small team a shareable application without a front-end engineer. Bokeh handles live monitoring. Altair keeps notebooks readable, and PyGWalker is for the first hour with new data. Size is the constraint people discover last. Browser-based libraries serialize your points into the page itself, so 100,000 cells is comfortable and 1,000,000 is not. Above that, aggregate before you plot, bin it, downsample it, or render density first, and keep interactivity for the summary. So the decision takes about 10 seconds. Does it go in a paper, Matplotlib or Seaborn? Does somebody need to click it, Plotly or Bokeh? Do they need to filter it themselves? Dash. Are you still exploring the data? PyGWalker. Everything beyond that is preference, and preference is allowed. Choose the library by where the figure ends up. Then spend your effort where it actually matters. Position for the key comparison, deliberate color, honest distributions, shared scales. The library renders the figure. You are still the one making the argument. Thank you for watching Multiome Academy.